Welcome back, everyone. Now, what we did last time was we took all of these 181 sprite slices from this sprite sheet, and we programmatically iterated over them, and we created a lovely JSON file, a giant JSON file. And this is an excellent thing to do to save you time if you want to create, say, a bunch of items for a role-playing game or whatnot, and you have the images and you haven't yet created the data. So we're basically creating a skeleton for that data. And what we did was we first of all we created a class called ItemData, and if you see here, I did change it since the last episode, which is I changed the image to a sprite because that's really what we want. We want the sprite because that's going to be more useful. So we basically created what kind of data we wanted our items to have, and in this case we kept it simple so that we could more easily illustrate the concept. And then we just iterated through all of those images and then created a lovely JSON file that we can pull in at runtime and that we can also edit anytime we want. And of course, editing all this stuff is going to be a lot of work, but it's a lot less work than generating every single one of these things by hand, right? So that's the idea, is to basically get the boilerplate down so that you don't have to do all this stuff. And you know, that stuff doesn't really have to be touched, right? And this probably doesn't either. So that's the idea. Actually, you could touch that. You could say great amulet, whatever. That's the idea here. Now, one thing we didn't do is we did this create, and that's something else that I did off camera, is I took the stuff that was in start and I just created a method called create JSON from sprite slices. Or I probably could say create JSON from texture 2D or something like that. Or from sprite texture. How about from sprite texture? That's much more clear, isn't it? So, and then we would take and copy this here. So you can see I just replaced that with a call to this function. So that lets us, if we want to do this again, we can just use this function again and write out another JSON file. That sort of just modularizes it. Something we didn't do, though, is we didn't pull that data in and test to see that it comes back, that we can actually deserialize it. So let's do that real quick. So first we need to grab the JSON itself, and that's going to be fairly simple because we can just say JSON equals, and we'll use the resources class. And really all we want to do is we want to load a text asset, and something that's nice about at least Unity 2018, and it may be with 2017 too, I don't remember, but .json files are now treated as text assets, which is great. Used to you had to rename them to .bytes or .txt, and it was really irritating, especially with you wouldn't get the color syntax or the syntax highlighting in your editor that you used, but now you can leave the .json on there. It's great. So let's load a text asset file, and the one that we had was items, and remember you leave off the extension, and then we just want to get the text out of that. So there, now we have the JSON. Then now all we need to do is deserialize it, and when we get what we get will be hopefully a list or a basically no, it's not going to be sprites. It's going to be one of these classes, right? So we'll say JSON utility dot from JSON, and it's going to be, we want that data class. We want to make it into a data class. So let's see what happens when we do that. And I'm going to just add a debug statement in here just so that I can break on that. We'll attach it to our Unity editor, and we'll head on back into Unity, and we'll play. And we're here. Let's check this data, and it looks like we've got all 181 items. Yep. Now this is still something we need to take care of. As you can see, it's a null, which means we haven't loaded the icon. So that's what we're going to do in this episode. We're going to figure out how we might go about doing that. First of all, let's create the the framework for doing that inside of the ItemData class, because that's where we'll have to do it. Basically, we want to tell the ItemData class, when you are deserialized, we want you to do something, run a method, whatnot. Well, there's a nice interface that you can implement for that. It's called iSerialization callback receiver. A mouthful, isn't it? I'm going to hit Control period and tell Visual Studio to implement that interface explicitly. You see it has two methods on after deserialized, which is called after the object is deserialized, and on before serialized, which is called before the object is serialized. We don't want to use that one. We want to use on after deserialized. What do we want to do? We want to load the correct sprite based off of the image name. Yes? So let's think about how we might want to do that as a, say, consumer of this class that we will write here in a minute. The class that we'll write, you could call it a library class or a database class. I'm going to call it just a database class because that's really what it is. It's grabbing a bunch of data, which in this case will be sprites, all those sprites out of that texture, and it will hold them and allow you to access them. And we're going to have it to where you can access them through one method, which would be just by the string. So the string will be the key. So what we might do is say, okay, well, let's try to find that sprite. So we want to grab the sprite. So we'd have something like sprite, let's just call it sprite data, dot, probably some kind of instance of a database of some sort. And then it would be cool if we could do an accessor like this and then just type in image name and then get our sprite. And then we could check and see if the sprite is null. Then we could debug.log error format and say unable to find. Actually, maybe we don't even have to do that. Let's just say if the sprite is not equal to null, then let's set it. Let's set the sprite, or actually, sorry, the icon equals the sprite. So we'll leave that there and comment it out. That's just kind of what we want it to look like. So we could do that and create a little database thing for that, specifically for that. But let's think more generically so that we can reuse some of this stuff just in case we want to create a collection of other things that we want to be able to access in that same manner, say with a string like that. So let's add a new class and let's just call it database. I'm going to get rid of the namespace because I don't want it. And let's make it public. Now, a database, well, this kind of database that we're going to do, we want it to store specific types of things. So let's make our database store things of type T, so that, which means we can make it generic. So it's going to be this is a generic class. And so what we will probably also want to do is constrain T in some form or fashion, but let's first think about this. What do we want first of all? Well, a database is really a simple database, which is what we're looking for, is simply basically a dictionary that's indexed by some sort of key and it gives you a value. Well, we already said that the key, we want it to be a string. And the value or the thing we want is that T, that type T, whatever it is. And I'm just going to call this dictionary the database. Then I'm going to create a constructor where we just new up that database like that. And so that gets us to here. Now to get that accessor like we did right here, let's implement that. So what we want is a public, what is it? This, I believe, because we want to do a, no, it's public. We put the type first, and it's this, and then we tell it we want this key to be a string, and we want to implement a get function or a get accessor, and what we want to get is that piece of data. And then we'll use the dictionary's try get for this. So we will try to get the key, and hopefully it will give us the data, and if it does, that will return true, and then we'll just return the data. Otherwise, what we want to do is we want to return null, but notice it's not going to let us do that because it doesn't know what t is. So we don't have a constraint on it. So it says t could be a non-nullable value type. We could return default of t, but that's not what we want to do. So what we really want to do is we want to put a constraint on t, and we want to say where t is a class. So if that's the case, we know that it's a reference type, and all reference types can be equal to null. Now, if we wanted to, but of course, let me back up real quick. If we want to use this and we wanted to actually pull items out of this thing and use the items and modify the items and change the items, say if we're using it for an RPG database, you've got to be careful, because if you pull one of those items out of this class, then you need to, instead of using that item, you need to copy it. You need to copy all the stuff in the item since it's a class, because you don't want to modify the original item in the database. So there's a possibility that you may want to instead, or at some point, you may want to create a struct database type of this class and then constrain t to be struct. Of course, that messes this up, but then all you have to do is come up here and say, well, instead of returning a type t, I want to return a nullable type t, and then that just gets rid of that. So with a struct, it's a value type, so whenever you set it equal to another one of those things, it actually copies it. So that's the nice thing about struct. But for now, we're going to keep it class. It's just something to be aware of. So we have our basic functionality here. And actually, that should really go down here according to the way I do things. But we also want to be able to add an object of type t, right? So we want to be able to just do this. But the problem is, how do we know what key the object has? Because it could be, this is just a generic type. It's just a type of something. We've constrained it to be a class, but we need to be able to get a key out of this thing. So let's make this type t whenever we derive from this database class, whatever we specify here. Let's say that it has to implement an interface, and let's call that interface, we're going to make a new interface. Call it, let's call it IID. And what we'll do, I'll just hit Control period and tell it to generate that interface for me, and I'm going to make it a public interface. Additionally, I'm going to bring it up to the top because I like my interfaces on the top. This will simply allow us to get an ID from that, whatever that T is. So basically, we'll know inside of this database class that any type T will have this interface, and then we can create something like a property and we call it ID, and we can say we require you to have a getter on that. So that's what we'll do. And now whenever we do an add here, we can just say, first of all, we want to check if the object is null, and we'll just return. And then we can say, the next thing we want to do is we want to see if the database contains a key of object, and watch now. Now I get the ID, which is exactly what I want. So that's what we will add. That's what we'll put our object into the database, what we'll use. If it contains that already, then let's just, wrong one. Let's log a warning, and we'll say database of type, and we'll go ahead and specify what database we're looking at. Already contains key. And so that type will be type of t dot name. So because we want to tell it what the database, what kind of database, what stuff we have in this database, what type of objects we are storing. And the already contains key, that's easy. That's just going to be object db.id. So we're using that ID as a key. Otherwise, let's just add it. Otherwise, db.add object.id, and we'll add the object. Simple as it can be. Right, ladies and gentlemen? Right. Something else we might want to have is we may want to be able to add, say, a list of t. Call them items or whatever. And with this one, we could just say if items equals null, or let's say not equal to null, then we just for each over them. Easy enough. And then all we do is we could just call the add that we just created. And also, if we, and for some reason, had instead an array of these items, we could still do the same thing. So we just overload that. And now we have this lovely little database class that we can utilize for any type that is a class and that implements this ID interface. So now what we want to do is use that. So we need to look at what we want. So what we want is we want a sprite. We want to grab a sprite out of here. So what we need is something like a sprite, and let's create it from over here. Let's create something called a sprite data class. That sounds good to me. Just a sprite data class. So let's come in here, and it's not going to be a mono behavior. So this sprite data class, we want it to store the sprite. But of course, since it also has to implement that ID interface, we will implement here. It's going to also have to have the name of the sprite, which we can use the new C#6 features, and we can just do it like this, which is really cool. We can just return sprite.name because we already said that's really what it is. So a nice compact little class, right? And so we can use that, but we want a database. As a matter of fact, a database like this, really, we only need to load it up once, and then it should just be available the entire time our game is running. So what we can do is we can come into this sprite data class, and we can create a database inside of it. So we'll just use the keyword static, which says, hey, there's only one of these, and we'll make a sprite data class, and we'll call it DB. So we're basically utilizing that database class that we just made, and we're saying we want a database of sprite datas. And then we can make another static property, and we'll call it DB, and then we'll implement a get accessor. We'll say if that database is null, so we'll create this lazily. So if we don't need it and we don't use it in our code, we don't ever load up any of this stuff and create all of this extra memory space. So we'll create it here, and then later on we'll return it, because of course a get requires us to return something. So we'll create that database here, and then what we need to do here is load all the sprite objects that we want in our database. And of course, we know how to do that from the create JSON. We have this right here. That's basically what we're going to do. We just want to load all the sprites in a particular texture. And in our case, we know what texture that is, and that's going to be under the graphics / the items texture, which is going to be this little fella here under this directory in the resources folder. And if you had more, you could just keep on loading them like that. Really what you would do is you would load them, and then you would do like a for each over those. I'm going to call them sprites because that's really what we're grabbing. So we're loading all sprites here. And then we simply just add those to the database. And it's going to be, we want a new sprite data. And we probably should use, we need a constructor that takes this. So I'm going to highlight this. I'm going to hit Control period, and Visual Studio gives me a nice option to say generate a constructor with that sprite data, and I will do that. And that's what this is right here. So now we can just say new sprite data, and we pass it the item. And voila, we're finished. And then, so you would just repeat this chunk for each additional texture that you wanted to load. You could make this into, you could do this differently, of course, to where you could load these things more easily, or add a load into the database class itself or whatever. But for our purposes and for what we're wanting to do, this specific thing, this works fine. This works lovely. So let's go back to our item data. Let's uncomment all of this, and then let's get this to work. So sprite data, got that now. But this will be like DB instead. So we'll grab the image name, and if the sprite that we get is not null, then it's actually going to be that sprite. So let's see. We saw that. Let's attach this and see if we've done it or not. So we'll run it. We're here. So now if we did this correct, we should have a bunch of item datas with the icon. And there it is. So that works. So now we have this cool little database class that we can reuse for other items that we may want to create in a similar manner. So I hope this was helpful, and we will see you next time.